Okay, it's Chuck and Nathan here again, Don Ruba's linear electronics class. Today we're going to do a tutorial on syncing sourcing sensors using NPN and PNP transistors. Okay, I had an old fella tell me the easiest way to figure out syncing and sourcing. Take a waterfall, for example. It's an old term. Your source is where your water's coming from. Your sink is where your water's going to. So if you have a sourcing sensor, you're going to have a syncing PLC, and vice versa. If you have a sourcing PLC, you have to have a syncing sensor. Okay, I'm going to do some formulas for my sourcing sensor, my PNP. I bench tested my photoresistor at 1.7 k ohms in ambient light. Okay, if I put my numbers in here to find out R2, which is going to be resistance you're going to have to set your potentiometer at, equals resistance 1 times 1 over voltage in, divide that by your voltage out, subtract 1. So if you plug the numbers in, you take 1700 ohms, multiply it by your equation, which comes out to 33.285, blah blah blah. Anyways, you get 56,585 ohms, or 57 k ohms. The next equation is your voltage out, which is your voltage divider, is resistance 2 divided by resistance 1 plus resistance 2 times your voltage input. There's your numbers, what I came up with. And our voltage out to activate your PNP transistor is going to be 23.29, which comes out pretty close if you add 0.7 volts that takes to activate the transistor. Okay, this is the circuit. What we have here, if you pan over to the page, right now we aren't taking it to the PLC. We're just taking it to the test load, which is just an LED and a resistor in series. And that's a 1 k ohm resistor. Okay, and if you pan back over to the project, you can really see how sensitive this is in room temperature. I'm just going to get my arm close. See how that's just my shadow activating that light. Can you pan into it? See how it's really sensitive. So we got it dialed in pretty good. Okay, when we remove our LED and our resistor, we're going to take our collector. We're going to run that to your input 1. You see this is a syncing PLC. We're going to take our common reference for this loop power is positive 24 volts. We're going to run that back to our power supply so they have a common junction point, common reference. It's very important or this will not work. We can demonstrate how and why right now. Okay, as you see, everything's hooked up the way it's supposed to be. If I put my finger over there, the bit will light up. Bit 1 is lit up. Now it's off. My finger's off. Now if I take that common reference off, maybe we shouldn't get nothing. Which we aren't. I got my finger right over the photos, so nothing's happening. So that's important to get your common straight. If it's a common ground or a common positive.
So right here we have a syncing sensor, the print. So we have 24 volts DC coming down to a potentiometer that is set for 79 k ohms. and that is coming down to a photocell, which will then go to common. And also it is splitting off going to your base of your NPN transistor. Now you have your collector here going to the PLC sourcing inputs, and all of this right here is what's inside your PLC. And then from your emitter, you are going down to the common, which will then go to the common onto your PLC. So right now we just have the setup now hooked up to the PLC, just a little light demonstration to show you how it works. So we have this, so as soon as you cover the photocell, the light will pop up. It's not as sensitive as the sourcing sensor, but it still works. So now we have this hooked up to the PLC. So we have our common right here going to the common onto the PLC, and that is the ground on the breadboard. And then for our input for their source, we have this hooked up to the collector on the NPN transistor. So if you go ahead and cover up this photocell, you can see on the PLC that the little light comes on. And that's all it does.
Hey, we're here, we're gonna check our transistor. This is a 3906. I know this one's good because I just had it in the circuit. So your emitter should be more positive than your base. So if you hook your positive and you're negative to the base, it's reading out 0.9. Should be the same with the collector to the base. Oop. You gotta make sure it's on the little diode on your meter. All meters are basically the same. Some are a little bit different. You just gotta look out, make sure it has that feature on it. Now I'm gonna go to a bad one. We know is bad. We had a little boo-boo. This is a 3904. That's a NPN. So your base is going to be more positive than your emitter. So we're going to hook the positive to the base. The emitter is 1, right? Yeah. And that one isn't showing very good signs. That's bad. So hopefully this helps you guys understand how to test them. We're going to go back to this PNP transistor. We're going to show you how the PLC can give you a false reading with its LED if the transistor is not in full saturation, which can really be troubleshooting because you're looking at the input, it's lit up when it's actually not. Okay, I'm going to try to get my hand close enough so it's in saturation but not full saturation.
Right there.
Right there. Now if you look at your logic, it's not on until I get down. Now it's on. So it's giving you a false reading just because this transistor is not full saturation, letting your voltage through.